So starting with why automation networks are insecure. With the evolution of automation, we've had possibly Ethernet connected devices, but a lot of what we use are legacy and non-Ethernet protocols, especially over time. So these protocols, for example, DH+, remote IO, many vendors had their own proprietary protocols they used for connecting their devices. Now, those protocols tended to focus on availability, sometimes speed, but mainly availability of just always being up and active over security. So a lot of these are unencrypted protocols. Modbus, for example, has been around for a long time. Modbus is an unencrypted protocol. I can, if I use something like a packet tracer, I can actually see the exact data going back and forth throughout these protocols. There was a natural segmentation when I used the non-Ethernet protocol. So remote IO, DH+ had a natural segmentation because they weren't an Ethernet type protocol. So because of that, what happened on the Ethernet network would not affect what happened on the legacy side. And also, once an automation system is up and going, this is still common today, it's rarely patched. The concern with patching is in an unknown state, in an unknown environment, it could potentially cause a problem, could cause downtime. So instead of taking chances, a lot of customers have adopted a avoidance towards patching, which carries its own risks. Now what's happened is when we had the natural segmentation, this was very common, but as we've upgraded our systems, as we've replaced our processors and put our devices onto Ethernet, then what that does is it turns the original application notes that we say here where we talk about availability and segmentation, and it kept them even though we were still on Ethernet. So we still focus on availability, but we've lost our natural segmentation. We no longer have an inherent difference between remote IO and DH+ and Ethernet because we're using Ethernet now on both sides. But we've kept the rare patching. Over time, this has grown to expand the lines. So we've gotten larger lines, maybe even added. So we have a lot of devices sitting on our Ethernet network now. And what's absolutely happening today is because of the benefits of folks talking about something like connected enterprise and Industry 4.0, we're actually connecting these devices in some way, shape, or form. And I'm going to simplify it in this diagram and show it directly connected to the internet. But it might just be connected to the business system. And the business system might be connected to the internet. So why would we do that? So we want to do something like data analysis. We would connect it to the business system so that we can have some higher level tools, crunch numbers, expose manufacturing data, production data to our logistics division to allow some sharing of data back and forth in enterprise planning. We might want to have remote access. If we have vendors that can troubleshoot the system, we can use remote access to avoid flights and save costs, or provide access to our own employees just from home or from various locations to take advantage of the virtual environment that's out there today. And then finally, just visibility. So management might want visibility into the system or integration into the other business systems. So there's plenty of benefits on why we would do this. But there is inherent risk if something comes through over the business network. What happens when we don't have segmentation and we don't have cybersecurity as our focus is something affecting just a PC on the automation system can actually take down our entire plant. Unfortunately, this is not uncommon. We've seen a lot of this happen with our customers, with customers globally. So it seems simple. If we just don't connect it to the internet, so if we just keep it segmented, it would seem that we would be then secure. Unfortunately, we're not. So there can still be other ways that folks can affect our systems. It could be somebody physically inside the plant. It could be an internal employee, either purposefully or even accidentally. It could be somebody that is breaching our physical security. Physical security is still part of cybersecurity because it's part of protecting our assets in our system. And when we don't have it connected to our business systems, we lose all of the benefits we just talked about. So we lose all the benefits and we're still not completely secure. So what we'll talk about is how do we still handle this? How do we balance the best of both worlds to give us the data we want, give us all the access, but still stay secure? So we said it's common. These numbers may or may not be surprising. $11.7 billion in the last 2 years are damaged to ransomware attacks. Ransomware is the locking out of a system to demand a ransom. So there's money in it for the folks on the other side. This might not be a targeted attack. It might just be an attempt to gain money via holding someone's system hostage. But also the other one I'll highlight is 53% of manufacturers have experienced a breach in their facility. That's a huge number of folks that have had a cybersecurity breach. And if we look at these over time, you may or may not be familiar with some of these. Some of these names are going to be common. Stuxnet is a well-known one that targeted nuclear centrifuges. WannaCry is a more common one that's gotten a lot of publicity. But what I want to highlight here is when we start looking at this back in 2010, so 10 years ago, it's a relatively low number of reported incidents. Now there could be more over time, but reported is relatively low. And we had a somewhat steady graph growing up and down throughout the past 6 years. And then all of a sudden it starts skyrocketing. So these are becoming more and more common. So when we get to that 53% number, it's because of how prevalent these have become. More attacks, more ways to be attacked, and our systems being more and more exposed to this level of the network. So you've seen the headlines. You've probably known folks that have been impacted by this. This is costing billions of dollars. It's shutting down manufacturing. And sometimes they're targeted and sometimes they're relatively simple. And that's what I want to highlight here. When we talk about Stuxnet, that was targeted to do exactly what it did. It was manipulating values in the PLC to damage equipment in the process. But something like WannaCry and a lot of the more recent ones, they're not targeted towards industrial control systems. And that's something of the dangerous part of this. They're not going after the ICS system, so the industrial control system specifically. They're going after all PCs. And it's more of a shotgun approach. And if we're not protecting ourselves from that level of a shotgun approach, then we're going to expose ourselves to a lot of risks. So how do we plan for this? So what we're going to cover is a before, during, and after. So how do we protect ourselves before an event even happens? Understanding our assets, talking about patch management. So we talked earlier that patches historically were rarely implemented. We need to find the balance between implementing patches because there are critical security updates. The WannaCry virus and some of the others, actually, if we cover the NotPetya as well, that actually was based on information that the NSA had, something called Eternal Blue, was a vulnerability within Microsoft. And the NSA discovered it, it was leaked. Once it was leaked, Microsoft actually came out with a fix for it. So there was a way to protect yourselves from that environment, from that risk, published by Microsoft with just a simple patch. But when we don't patch, we actually lose all the benefits of something like that from a security perspective. So we need to understand what patches we should apply and a safe way to apply them. Talk about some security functions we can build within the zone. And then once an attack happens, being able to detect it quickly. There are statistics that it takes a long time to maybe even months to discover that you've actually been exposed to an attack. So how quickly can we detect that attack is happening before it spreads? Because they can spread over time, some quickly, some slowly. But the sooner we know there's a problem, the sooner we can react and respond. And once it does happen, if it does happen, how quickly can we recover? Having good backups of the system, having a plan in place to recover as quickly as possible, something of a thought out system.